Hey guys, what's up? You are on the Pick of the Week with Daniel Dallas. Today I've prepared something special. That's A-level stuff in IBHL. So this is Trigonometric Equations. You might have a look. If you're ready, it's right time to know whether you're able to solve that. So can you solve this? Grab your pens, grab your notes, and let's get started. So we have trigonometric equation, and we also have the limits for x. So let's see how it works. We have limits for x from 0 to pi, or if you prefer degrees, so you can rewrite as from 0, including the boundary, from 0 to 180 degrees. All right, so that's our boundaries. However, we need to solve that. Cos squared x plus 4 sine x equals 4. So my strategy is to try to recognize the structure. I see cos squared, I see sine x, and I see just a free number. It has a high resemblance with quadratic equations, so that's why I'll try to use the strategy using quadratic equation structure. And in this case, I'll be thinking about cos squared x. So what I can do here, I can rechange and say that cos squared x is simply 1 minus sine squared x using trig identity. So this is trig identity. Actually, the result of Pythagoras by applying some ratios, trig ratios. All right, so having that, we'll have the following in our equations. 1 minus sine squared x plus 4 sine x, and I transfer 4 here so that I have this form. Okay, so now I can see that if I input new variable for sine as t and for sine squared is going to be t squared, and definitely will have quadratic structure. So our t is the variable that I marked as sine x. But as you remember, because sine x, it has the limit from -1 to 1. It cannot exceed 1. It cannot exceed -1 in negative direction. So we have some limitations for our t. So t cannot be more than 1 and less than -1. All right, so I rewrite this in the following way. I don't like when leading coefficient has negative sign, so I'll rewrite as t squared minus 4t, and if I simplify that, I finally get plus 3 equals to 0. So make sure you understand how I got it. And now it's time to use factorizing. So I'll get t minus 3 and t minus 1 using factorizing instead of quadratic formula, because it's quite easy. From where I'll get t1 equals 3 and another root for our equation t2 equals 1. So 3 actually exceeds 1, so 3 doesn't work, and we are saying that it doesn't work, and we're going to use t2 equals 1. So that's why we come back to our x, and we're writing that sine x is 1. Okay, so just remember, if you know that, like what stays for sine x, when it's equal, what stays for x if your sine x equals to 1, no problem. But I'll show you for those who are still struggling with the unit circle. So let's say that's unit circle. This is y and this is x-axis, and we know that sine x is the vertical values during rotation, or radius position vector in the unit circle, so that we can get sine x to be 1. So sine x to be 1 when our position vector has an angle 90 degrees or pi over 2. So that's why in this case sine x equals 1 when x is equal to pi over 2. So that's why this is our first solution. But the general, like, we know that sine x is periodic function with a period 2 pi, So that's why it repeats its value when we add 2 pi rounds times n, because we can take several rounds, where n is from z, means whole numbers, positive, negative. So that's our whole general solutions, and we need to pick up those which are from 0 to pi. So that's why if you test when n equals 0, you'll get your basic point or starting point, pi over 2, and if you plug 1, you'll get x equals 2. So pi over 2 plus 2 pi, that's definitely will exceed your range. Okay, and even if we take n equals -1, we'll get x to be -2 pi plus pi over 2, which becomes negative. So that's why only one solution fits to our range, and this is x equals pi over 2, which is the solution for our boundaries. Okay, so I hope you understand. It was pretty clear. And let's get to the next problem. So problem 2, we need to solve for x when x is from 0 to 2 pi, the following equation. Alright, so let's get to the points. We have 5. We can expand first of all. 5 square root of 2 sine x over 2. And on the right side, we have 2 cos x. How we can write the last one? Instead of cos x, I would write 2 and x over 2, because finally you come back to x. Okay, why I did it? Because I noticed that the argument for the sine function is x over 2. So guys, try to have the same argument in another function. But because the primary goal is for, and this is universal way how to solve Trig's equations, is to get single function, single trigonometric function, either cos or sine in this case. So I would like to come from cos 2x over 2 to sine of x over 2, maybe to some power. So how I can do, I will use the formula for cos 2x. So cos 2x is cos squared x minus sine squared x. But I'm not satisfied with cos, so that's why I also want to get to sine squared. So that's why finally I'll get cos 2x is 1 minus double of sine squared x. Okay, using trig identity, I just use, instead of cos squared x, 1 minus sine squared x. Okay, I can write, if you like, cos squared x equals 1 minus sine squared x, and hence I just plug it back. So however, I would like to apply this formula into my particular function, which is cos 2x over 2. So that's why I write as 2 and x over 2. I just simply switch x into x over 2, and I will have the same structure. So sine squared of x over 2, and that's how we can get the rechange. So writing our equation, we'll get the following. So 5 minus 5 square root of 2 sine x over 2, and that will be equal to 2 minus 4. I expanded the brackets simultaneously, and I write in sine squared x over 2. Okay, now I can see that right now I have sine x over 2, and I'll also have sine squared x over 2. And as you remember from the previous problem, we can mark as t. So that's why we do rechange sine x over 2. This is t, okay? And as you remember, t should be within the range from -1 to 1. Okay, so now let's get back to the equation and plug t values and also rearrange so that to have quadratic form. So quadratic form right now is going to be So 4, I transfer 4t squared to the left hand side, so I'll get 4t squared, okay? So next part, what I'm gonna do, I'm writing the t term, which is 5 square root of 2t, and when I transfer 2 here to the left hand side, I will get plus 3. So right now I've got purely quadratic one, and because like irrational coefficients I can't factorize easily, so I would like to use quadratic formula. Okay, so guys, use quadratic formula and get the values. So t1 is simply square root of 2 over 2. So what about t2? Use your calculator if you like. 3 square root of 2 over 4. So which works? Oh, obviously only this works because that exceed 1 and means it doesn't work. Alright, due to our limitations. So that's why I go back to sine x over 2 and we write sine x over 2 equals to, so in this case, square root of 2 over 2. Alright, again, you can go back to basic unit circle and figure out square root of 2 over 2. So I draw this unit circle right here. Okay, so here I just want to show you how we can get easily value. If you like, you can use calculator, but I'll show you how to do it mentally. So square root of 2 over 2, that means we are going to use angle of pi over 4. So that means I'll get square, so here's the value for sine, square root of 2 over 2, but I can get using the angle pi over 4 and also another angle which is here, so one more time, which is here. It will also give me the same value. However, the reference angle is pi over 4, but the total angle is pi minus pi over 4. So I mean this one. So have a look. I mean this one. So this angle stays for pi minus pi over 4. So for x over 2, I'll have pi over 4 plus 2 pi n, right? And for x over 2, I will also have angle pi minus pi over 4, which is 3 pi over 4, and again plus 2p, let's say another k. So both n and k from z, so and k, they are from z. Alright, so I squeeze a little bit, just lift it up. Okay, so what I'm gonna use right now, I'm gonna use right now our limitations for x. So x from 0 to 2 pi, so take into account that x from 0 to 2 pi, I'll leave only, first of all, I need to express x from here, and only then I can decide which value fits to our range. So I both parts multiply by 2, and that's how I can get x value from the first one. It's going to be pi over 2 plus 4 pi n, and for x2, I will also have 3 pi over 2, because 2 and 4 will be cancelled, and 4 pi k. Okay, so let's test the values. Obviously, for x values, if you start like running 0, plus minus 1, plus minus 2, and so on, let's plug and see that x1 pi over 2 works, so we'll get pi over 2. If we plug 1 and first, so that doesn't work. What if we plug negative? It also doesn't work because it will be negative 4 pi plus pi over 2 is going to be with beyond the range. So that's why for k, 3 pi over 2 and 4 pi k, that also works only one value, 3 pi over 2. So that actually becomes solution for our equation. So I hope that it wasn't like pretty long because we discussed two problems at once, and you can see now the complete solution here. So you can have a print screen, and this is complete solution, how it works. That was Daniel Dallas. That was pick of the week. Thank you guys to be that you're with me. If you're new here, please subscribe. Actually, you have lots of benefits as a subscriber, and actually don't forget to smash the bell button to be notified about daily video, and on a weekly basis here is the pick of the week, specific collection for interesting problems that at least I pay attention to, and that's how I deliver it to you guys. Thank you and peace out.